Hello everyone, how are you all doing today? In this video, we'll solve the integral of 1 over cos x minus sin x. It's a very interesting integral and it was also asked in JEE Main 2004 paper, so you can understand the importance of this integral. I'll show you a method via which you won't be able to just integrate this particular function, but you can integrate any integral which is of the type 1 over a sin x plus b cos x. Remember, whenever you want to integrate 1 over a sin x plus b cos x, or in other words, the function which is linear in sine and cos in the denominator, there are two methods to integrate that. Method number one is you multiply and divide the denominator by square root of a square plus b square. And then you can apply the compound angle formula. I'll exactly show you how to do that method in this video. Method number two is Weierstrass substitution. Weierstrass substitution is essentially a substitution of tan of x by 2 is equal to t. If you want to see the full video of how and when to do Weierstrass substitution, I have attached a video on the top right now. It is the best explanation of Weierstrass substitution on the entire YouTube. I promise you won't regret it. So do check that video out. Alright, now let's focus on this integral using method number one. Method number one says you divide the denominator, multiply and divide the denominator by square root of a square plus b square. In this case, I have the value of a is 1 and the value of b is minus 1. So I say multiply and divide denominator by square root of 1 square plus minus 1 square. Okay, because a is 1 and b is minus 1. So this will turn out to be square root of 2. So essentially you have to multiply and divide the denominator by square root of 2. Let's see what happens when you do that. So you have integral of 1 over divide by square root of 2 in the denominator. So 1 over root 2 cos x minus 1 over root 2 sin x. And since you are doing divide by root 2 in the denominator, you will have to also multiply by that root 2 in order to nullify that effect. And you have dx over here. I hope that makes sense so far. And that root 2 in the denominator is constant, can be taken out of the integral. So you have 1 over root 2 integral of 1 over. Now, we have to apply the compound angle formula over here. In order to apply the compound angle formula here, that 1 over root 2 and 1 over root 2 can be written in the form of a sine or cos, whatever you prefer. So in this case, let's say 1 over root 2, I can write it as cos pi by 4. Because we know that cos of 45 degrees or cos of pi by 4 is 1 over root 2. So I can write that as cos pi by 4. Then I have cos x. And that 1 over root 2, the other 1 over root 2, let me write it as sine pi by 4 and sine x. Why do I do that? Because the moment I do that, I can apply the compound angle formula in the denominator. How can I apply compound angle formula? Because we know cos of a plus b, the formula of cos of a plus b is cos a cos b minus sine a sine b. And if it was a negative here, there would have been a positive here. Okay, that's how the compound angle formula of cos works. So what you can do here is that term cos pi by 4 cos x minus sine pi by 4 sine x can be written as cos of a plus b, where a is pi by 4 and that x is b. So what you will have is 1 over square root of 2 integral of 1 over, I have cos of pi by 4 plus x and I have dx. I hope that makes sense so far. And now that 1 over cosine is nothing but sec, so you can write it as 1 over root 2 integral of sec pi by 4 plus x with respect to x. I hope that makes sense so far. Now the integral of sec, so there are two formulas for integral of sec x. Let's look at both of those together. So when you say integral of sec x, the formula number one for integral of sec x is ln of sec x plus tan x. The other formula of integral of sec x is ln of tan of pi by 4 plus x by 2. Essentially, the difference between these two results is the angle. In this case, the angle is x. In this case, the angle is x by 2. So it depends on which answer do you prefer, which angle do you prefer. Do you prefer x or do you prefer x by 2? That sometimes depends on the multiple choice question. If it's a multiple choice question that you are answering, if your multiple choice answers are in terms of x by 2, you would prefer this result. If it's in terms of just x, you would prefer this result. In this case, let me just use the first one, ln of sec x plus tan x. So I will have 1 over root 2 ln of mod of sec pi by 4 plus x plus tan of pi by 4 plus x. Let's close the mod, plus let's add the constant of integration c, and this is nothing but your final result. In this case, coefficient of x is 1, so it doesn't matter actually if you don't divide by 1, but remember in integral you generally have to, after integrating, divide by the coefficient of x. So your final result over here would just become 1 over root 2 ln of mod of sec pi by 4 plus x plus tan of pi by 4 plus x. Let's close the mod, plus let's add the constant of integration c, and this is nothing but your final result of this integral. How interesting but easy was that integral? I hope that made sense. If you understand the concepts that I'm teaching you, can I request you to like this video and subscribe to this channel? Also, I do post math and calculus content every single day. That's other reason to subscribe. I'll see you tomorrow.